Welcome, everyone. Today's SIG Talk IT operations topic is around a solution called OpenStack Cloud, and maybe possibly discussing some SUSE integration points as well. So welcome. Thanks, everyone, for attending today. This is a rescheduled event that we had a few weeks ago where we had some technical issues with GoToMeeting. So thanks for coming back. And if you weren't here last time, but you caught us today, so this will work out well. So welcome to Vivid SIG Talk. This is a monthly call that we do that discusses practitioner discussions around products, product integrations, these kind of things, and just a way to help you as Micro Focus customers learn about things that may be relevant to what you're doing in various things within typically IT operations. I think this kind of stretches that by going into some of the cloud technologies, but I think it's all relevant and thought it would be great to share this content with you today. My name's Rocky Pisto. I'm the Vivid Engage Coordinator and a SIG leader as well, so I've been very involved in the ITOM space for longer than I've had gray hair. So love to share this with you. And today's presenter is Dr. Kenneth Tan. He's the director at Sardinia Systems, and he's going to talk about their case study that they've done with the University of Edinburgh, which is kind of neat in the education sector. If you have questions, you can, we'll show you how to do it on here on the website or in this webinar. Also, you can send it to Vivid SIG Talk on our Twitter site. This is a live session that's being recorded. So the recording will be available for those that have registered and weren't able to attend today. You'll be getting a notice from us as well with the recorded session and answers to all the questions that may come up during the session. So just type your questions in the question pane, which is right here. Down at closer to the bottom of the panel, you'll see an arrow that you can toggle back and forth to get to the question pane area. And we'll try to address those during the call. If not, then you'll see it after the fact. So with that, I think I'm going to turn this over to Kenneth to kind of tell us what they've done here at the University of Edinburgh.
Thank you, Rocky.
You bet.
Just trying to get the presentation onto my end.
If you haven't, I can move the slides for you, Ken, if you can see.
Can you see my screen now?
I think I still have the screen.
Okay, so let's continue with you driving the slides. Okay. So before we go on,
first slide. There we go.
Yeah. So today I want to talk to you about the road to OpenStack at the UK's largest academic private cloud at the University of Edinburgh. My name is Kenneth Tan. I'm from Sardinia Systems. Rocky, can you turn to the next slide, please?
Yes.
So first off, how many people have deployed OpenStack? How long did it take? And did you roll your own distribution of OpenStack? Now, usually when I do this presentation live in person, there would be a sizable part of the audience that would have said, yep, they have deployed OpenStack. How long did it take? It varies, but invariably the answer is long. Did you roll your own distribution of OpenStack? Some people have tried, and invariably all agree that it's a very bad idea. And how many people have had upgrade problems? And that is the question where virtually everybody in the audience would say, yep, we have had upgrade problems. So now if we turn on to the next slide, so let's get some background on who is the customer. Rocky, could you turn to the next slide, please? So just to set some context, the University of Edinburgh is one of the leading universities in the world, amongst the top 6 in the UK. And depending on whom you talk to, number 6 or number 7 in Europe. It's founded a little while ago, 1582. Yes, it is indeed older than some countries. And it's got a sizable population, circa 45,000 people, with undergrad, postgrad, admin, and academic staff. So not a small organization. But then when we look at the IT operation side of things, there is a part of the university's IT operation which is called research services. Research services is in turn part of IT infrastructure division, which then forms part of the university central information services operations. This part of the organization is responsible for operating the university's IT infrastructure for research, which in the university's terms basically means everything other than the pure admin workloads. So pure admin workloads would be, for example, payroll, timetabling, etc. Within the research services side, there are only 10 people. So quite a compact organization that they invariably then have to think very strategically about what they can deliver and what's the objective. So the university have adopted this principle of a shift left strategy. So essentially, you want to move as much of the services to be self-service, built on automation, to allow the core staff to focus on higher cost services to be delivered through in an efficient manner, and to enable high value HR and deliver high value services overall. And when it comes to the cloud, the objective really is to provide flexible infrastructure for compute, storage, networking, and services for research, and ultimately to drive high value HR and deliver high value services. So now with that in mind, where does OpenStack sit in this picture? What OpenStack can do is to provide users with a flexible self-service provisioning of compute infrastructure. And this spans the full spectrum of compute, storage, networking, and applications portfolio. And for the research services operations, OpenStack should not be a net increase of workload for research services team. Additionally, where OpenStack needs to be is to serve a broad range of users. Each one of them have varying and competing needs, and the infrastructure has to then be able to deal with a mixture of both long-lived and short-lived workloads as well. And in and amongst those would be HPC technical computing workloads, for example, CERN workloads, particle physics workloads. They also have some data science workloads building on Hadoop, Spark, and some teaching workloads. And it's very critical for them that they cannot make assumptions about the user's level of technical expertise. But prime amongst those is the need to meet the organization mission. And they also realize that they cannot just throw money at the challenge because money doesn't grow on trees. At this point, they brought in the partner, and hopefully not in crime. This is Sardina Systems. We are a European cloud platform software vendor with presence in Slovakia, Romania, Russia, and the UK. Our focus is primarily around enterprise, with the team's expertise in large scale and business critical operations in sectors from finance into defense, government, meteor, and auto industries. We are one of the OpenStack Foundation corporate sponsors. And so when we were brought into the university, we worked out a solution with a customer. Now, in terms of route to solution, we tabled with a client that there are essentially two options: either A, adopting the Sardina standard solution architecture, or to go down a custom design route. In this case, the client decided that they would go down a custom solution route. And so what we then did was to go through with the client from problem definition and solution design into system architecture, hardware specification, and going down to project management to really understand what's happening when and by who. The hardware element, it is quite important as well, because in this situation, we have to provide down to the BOM level very specific part numbers for the hardware vendor's parts. Otherwise, the hardware vendor, in this instance, would take a substantial amount of time to put together the solution. So when we then look at how do we get from the initial point of initial engagement to the point of full system operation, we have to plan for production from day zero, and the system is built for production from day zero. We've always taken the view that this is not a toy, and so therefore high availability is not optional. And then it's also very clear that when we want to scale up the system, it should be monkey capable. And it is also very clear that we cannot treat a client as a guinea pig. So we do not do anything that is experimental on the client systems. And we have to consider the full life cycle of the system, from deploy into operate and subsequently into upgrade. Now, for some technologies, this life cycle from deploy into operate into upgrade can be quite long. But in OpenStack, that is just 6 months. at most. So let's look at the solution design a little further. In this situation, for management, there are 16 nodes, storage comprising 9 Ceph nodes, and compute 200 plus nodes design size, and the network is run as 5 VLANs over 10 gigabit Ethernet. And the system then integrates with the broader university IT services. And it's relatively simple hardware configuration. The system can be resilient to half the management nodes being down. So from there on, looking at the deploy phase, as we enter deployment, first we need to know what's the ingredients, what are the ingredients, what's the configuration needed, and making sure that the ingredients for the system is ready. The hardware are all available, server, storage, networking, and it's crucial that we have a single source of truth for the full system configuration. And with the system configuration, which then equals the input for automation, and the deployment system can then bring up the full system in a fully automated manner. By being able to do this in a fully automated manner, it also reduces project risk and thereby increasing operational confidence of the client. So with the view that what we do is we need to automate. The base OS deployment is done as part of standard in the organization. Post base OS deployment, there is some system configuration with SALtStack. And after that, the full OpenStack and Ceph deployment with FishOS deployer using the SALtStack variant. We have 2 variants, the SALtStack variant and the Ansible variant. And the principle here is rely only on standard enterprise tools, nothing fancy at all. So we have input, which is the configuration and inventory files, run the deployer, add 2 cups of coffee, and we're done. That's the whole objective of making it dead easy. So from concept into reality, how do we achieve this? Config file, run deployer, and add 2 cups of coffee. To be able to achieve that, the deployer needs to be pre-tested, proven offsite. It's a fully automated CI/CD process, and it assumes no knowledge of OpenStack necessary. Next, when we come to implementation, proving of the solution. First, there is detailed planning, knowing what is to be done when, what will be done when, and who will do what by when. along the way, we have knowledge transfer to the client so that the client understands why those actions are being done. And the time from 0 to operation was just 8 weeks, and 6 weeks of which waiting for storage hardware to arrive. Now, if we then fast forward to look at the upgrade phase, an upgrade, what is required? Okay. So now, first off, we need the system to run at all times. And we also know that we need to do N to N+1 upgrade every 6 months. And the releases are end of life in 12 months. So there are some folks who see that, well, why don't we do an upgrade in N years? Well, if we do that, there would be 2 N upgrades N years later. This is quite a risky proposition. And since this is not a toy, and we need a system to run all times, so what do we need? Well, we therefore need zero downtime upgrade. And here is where getting the solution architecture right from way back in the deploy phase becomes critical. Otherwise, you find out problem 6 months later that, oh dear, upgrade is a problem because of the choice of solution architecture 6 months ago. And certainly, this needs to be a monkey-capable, fully automated upgrade process. So now, let's switch our focus back into the operate phase. Hopefully, a system that is properly deployed and can be upgraded confidently and reliably, the majority of the 6 months is going to be spent on operate. Here, as an operator, you'd have a number of challenges, amongst which are uptime and availability, resource management. How do we operate in a infrastructure as code model? And we need the system to be idempotent so as to be flexible to change at any point in time. So delving further into reliability, uptime, and availability, we know that high availability is not a luxury. And if we take cloud model, we separate them into 2 parts, the service consumer versus the operator. The service consumer is only interested in availability and reliability. The service consumer doesn't care about how that's achieved. And for the service consumer, at any time that any service is not available, this is equals to downtime, whatever the cause may be. So if we then take downtime during operate phase, we can then further divide them into 2 types: intrinsic downtime risks versus extrinsic downtime risks. Let's first focus on the extrinsic downtime risk. Extrinsic downtime risk, broadly, we should be able to deal with them with a highly available solution architecture. Let's take a step back. Let's look at what is OpenStack? In essence, OpenStack is a series of intercommunicating services. It's got HTTP, MQ, databases, and that's about it. Not much more. And then when we look at the services, there are two types of services. Services with data and configuration versus services that are configuration only. So in relation to services with data, safeguards around availability is quite simple. It comes down to replication, replication, replication. And here, we either use a two-node model or a quorum/odd node model. So really, this is classical high availability operations model. If we look at HTTP, it's a web server. So let's treat it as web server and let's run it as high availability for web servers. What about MQ? Well, what's the principle of MQ? Principle of MQ is that we put stuff into the queue, we take stuff from the queue. Therefore, we replicate the reader and the writer. That's it. So, in short, for extrinsic downtime risk, we keep an extra copy available at all times. Where are the smarts? The smarts is in the solution architecture. Get it right, or else it can come back to bite you. So for a production site, what else is needed to run the private cloud service? Well, for a start, we need usage accounting and billing, log and metrics management, monitoring, capacity planning, you know, the usual stuff in enterprise systems management. So what about the problems encountered in operations? Over the last couple of years when they've operated the system, yeah, they have encountered a number of problems. For example, downtime due to running out of disk space affecting Ceilometer and MQ. The networking hardware problems resulting in packet loss. This is still being investigated. It's likely a problem on the part of the hardware vendor with the wrong transceivers that they supply for part of the system. With Cinder, one of the OpenStack components, there was a problem encountered during the Okata upgrade. So Okata being one of the previous OpenStack releases. And so now, nearly 2 years later, where are we? Well, the system's been growing, it's been working well, growing. They've undergone a number of system expansions in storage and compute. It's very easy to add a compute node as necessary. In the coming weeks, they'll be growing the system by another couple thousand cores. And amazingly, the system can be supported by just one person. Not that they only allocate one person, but it can be handled by only one person. What are the lessons learned? First, you didn't spin your own Linux distribution, so don't spin your own OpenStack distribution either. Second, it's not just planning, but rather experience plus planning, and more experience plus planning. And thirdly, quite importantly, make sure your vendor is able to support operation when needed. What about the other part in the bag that we provide to the university? The other parts are really there to round up the requirements of a OpenStack, production OpenStack site, encompassing log management, monitoring, service management, health, resource management, capacity planning, and so forth. This bag is then delivered in either software only, fully integrated with hardware, managed, hosted. But the principle is quite simple. It's built to just work. Providing products that enable the customer to very easily run a cloud environment, or to a service partner that can then very easily provide this cloud service to their customers. Our principle is that we focus on building the technology that can then be amortized across large operator base. We also have user onboarding for customers to enable the service consumers to gain certain familiarization, to provide operators with training, as well as self-serve training videos. Aside from the university, we have a number of SUSE implementation sites. In Norway, a service provider brought up the system essentially within about 3 hours. So the hardware was up by 2 o'clock and the cloud environment up by 5. In New York, in the US, one of the top 10 traders on New York market runs SUSE with 4 sites globally, managed as one. And one of the major European banking groups with 3 data centers in the HQ location implemented using SUSE solution blueprint. We brought that up in a couple of weeks. At a government site today, there's a client that runs 150,000 VM in one single site. And in other parts of the UK, there are major research sites, as well as aerospace design facilities. Questions?
Let's see. Trying to see if we have any questions here. I don't think I see any right now, Kenneth. Is there anything that came up during the implementation at the university that was kind of unique to their environment that may have caused some issues?
The university, they were very keen on reusing existing hardware to bring up their first system, and then to be able to quite simply replace nodes as they go along. So any one of the management nodes can be taken down to be replaced by a new node at any point in time. So this sort of design enables them to very simply and dynamically upgrade their system as they go along. In fact, if you look at their first storage system, that was also entirely running off spinning disks, and it was intended to prove concept, and they subsequently brought in newer and much more capable hardware to replace, and then we migrated across from the older nodes to the newer nodes.
Was this their first experience in the private cloud space?
Yep, indeed. It's their first foray into private cloud, and today they are the UK's largest private cloud system.
And did they have any issues integrating with external cloud systems, with other vendors, that kind of thing?
So if we look at clouds, we have the duality of the service consumer versus the operator, and in order for integration with external providers, what they have done is to provide a Terraform environment to allow the users to spin up workloads, whether within the university's own private cloud, or to spin up workloads directly on AWS, Azure, etc. And
Great.
Because these are directly under the control of the service consumers, it is not the university central IT's bill. They just provide the capability, but don't pay for that bill. It would be the service consumers themselves who are then responsible for the bill.
Okay. So you mentioned that it's really one person running this. What was the ramp up time for that person to understand how to make this work?
So we have a service model with the client, whereby the client could turn over to the Sardina team to operate the system at any point in time, which provided the client, especially in the initial phases, with the confidence that there's somebody backing them. The client took probably a period of about 2 to 3 weeks to get fully familiarized with how they would operate the system, and this was part of the implementation time. So the implementation time, part of the days in those periods were spent on providing knowledge transfer.
Okay, great. Great. Those are some great answers. I mean, I'm trying to think from a end user perspective how they would implement this, and I know part of the problem is getting management behind it to support a solution in this environment. So it looks like you guys were able to accomplish that, and not only win the company, but also get the end users that are responsible for maintaining the system to engage and to make the system work. So that's pretty key. And I think those are some of the tough things.
in a large community like the university, it is important to get the service consumers, i.e. the eventual end users, on board. So very early on, we engaged with one of the user communities around Hadoop and Spark workloads, the data science workloads. They were indeed the first user community targeted for this particular cloud. And for the user documentation and training, something that Sardina could provide to clients is to address this rapid change of OpenStack. Some sites, with various application sites, usually want to maintain their own on-site documentation, but with a fast-moving nature of OpenStack, this is a non-trivial feat. So Sardina takes the view that, hey, if you can learn to cook with YouTube, why can't you learn to use OpenStack with YouTube? And thus we provide a set of customized videos custom to the client's specific site.
Great. No, that's great. That is great. So I think unless you got any closing remarks, Ken, we're going to go to the Vivid update at this point. But
sure.
This was a great presentation. I think the information would be valuable to our members and kind of learning how the OpenStack system type works and how you guys do it at Sardinia. So thank you for your presentation.
Thank you, Ken. Thank you for having me.
And thanks for rescheduling after the snafu last a few weeks ago. So thanks, Ken.
Thank you for having me.
Again, you bet. Thanks for all that attended today, and we'll see this on a recorded session as well. Our next SIG talk right now is scheduled in the ALM space for September 13th. We're nailing down our ITOM events for September and October. If you'd like to present a case study or something that you've done that's unique in your company with any of the ITOM tools, we'd love to kind of hear what you have to say. Typically, the presentations are 12 to 18 minutes, so it doesn't have to be a long presentation, just diving into a specific area that's helped you make the product work better, that you think others could leverage that as well. So just reach out to me, Rocky Pisto, or rocky.pisto@vivid-worldwide.org. And we'll try to get you on the schedule. Like I said, we do this every month. Coming up in, I think it's in September as well. Yes, September 25th is the Cybersecurity Summit 2018 in DC. This is the what was Protect conferences. It's been renamed and probably addresses many more things to complete the whole raft of the cybersecurity components that Micro Focus has as for their customers. So looks like it should be a great event coming up in September. And hopefully you'll see a little survey at the end of this thing. Please fill it out. If there's things you'd like to hear more about that you're not seeing addressed, let us know, and we'll try to find speakers. Or again, if you'd like to talk for a few minutes, it's a great way to network with your peers and to get some exposure for yourself. And again, we enjoy doing that. So with that, I'm going to end the SIG talk for August and look forward to hearing from you and listening to what we have coming up in September. And with that, I bid you adieu. And again, thanks for attending. Good day.